Welcome to Stats Chapter 5, Lesson 2, Basic Probability Rules. So we're looking at probability models, which are descriptions of some random process, and that description needs to include a list of all possible outcomes and the probability of each outcome. The sample space is a list of all possible outcomes, and an event is any collection of outcomes from a random process. Remember, all probabilities are numbers between 0 and 1, and all possible outcomes together must have probabilities that add up to 1. So if I roll a die, something's going to happen. Something. I don't know exactly what, but something will happen. And the probability of an event can be found, and we call that event A, just for examples, using the formula where the probability of event A is the number of outcomes in event A divided by the total number of outcomes in the sample space. Or the probability of A is what you want divided by all the things that could happen. So, for example, a spinner has 3 equal sections, red, blue, and yellow. Suppose you spin the spinner 2 times. What is the probability model for this random process? So you could roll a red and a blue. You could roll a red, then a yellow. Or you could roll a red, then another red. You could also roll a blue, and a blue, then a yellow, or a blue, then a red. Again, order kind of matters here. Or you could roll a yellow, then a blue, a yellow, then a yellow, or a yellow, then a red. So if event A is spinning at least a blue at least one time, find the probability of A. So the probability of our event is the number of outcomes that involve a blue at least once. So I got 1, 2, 3, 4, 5 out of a total of 9. So the probability of rolling a blue here, if you roll twice or spinning twice, is 5 out of 9. If you want that as a decimal, 5 divided by 9 is about 0.556. So if that's the probability of an event happening, we can also look at the probability of an event not happening. That would be called the complement. The complement of A is written as A with a little c superscript. So if we know the probability, if we want to know the probability that A doesn't happen, we'll just take 1, something's going to happen, minus the probability that A does happen. And we would read that as P not A equals 1 minus the probability of A. So imagine you're rolling a red 6-sided die and a blue 6-sided die. Both dice are fair, meaning that the chances of landing on any side on top are equal. So find the sample space for rolling a sum of 6. So if you've got a red and a blue, the red could be a 1 and the blue a 1, the red a 1, a blue a 2, a red a 1, a blue a 3, a red a 1, a blue a 4, a red a 1, a blue a 5. We'll keep going. If red is 1, blue could be 6. Those are all the possibilities where red is 1. Or red could be 2, blue is 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. Or the red could be a 3 and the blue a 1, 3 and 2, 3 and 3, 3 and 4, 3 and 5, 3 and 6. Or the red could be a 4 and the blue a 1, the red is 4, the blue is 2, 4 and 3, 4 and 4, 4 and 5, 4 and 6. Or the red could be a 5 and the blue a 1, 5 and 2, 5 and 3, 5 and 4, 5 and 5, or a 5 and a 6. Or the red could be a 6 and the blue a 1, the red a 6, the blue a 2, 6 and 3, 6 and 4, 6 and 5, 6 and 6. So that is our sample space. So use the complement rule to find the probability of rolling anything other than a sum of 6. So we want the probability of not 6, the complement of a sum of 6. Or actually, let's be more clear about that. Probability of not a sum of 6. So we might need a short list of how to get 6. 6 could be a 5 plus 1 of any sort. 6 could be a 2 plus 3 of, 2 plus 4 of any sort. Or it could be a 3 and a 3. So that would be 1 minus the probability of getting a 6, since there are fewer possibilities of getting a 6 than there are not a 6. It's a little bit easier for us to just find the smaller number and subtract. So anytime I've got a 5 and a 1, that would be a total of 6. Anytime I've got a 2 and a 4, either a 2 and a 4 or a 4 and a 2, that would make a total of 6. And then anytime I've got a 3 and a 3, that would be a total of 6. So it looks like I have 1, 2, 3, 4, 5 totals of 6 out of 9. So 1 minus 5/9 is kind of 9/9 minus 5/9. So there is a 4 out of 9 chance that we end up rolling anything other than a 6, or that would be about 0.444 if you like the decimal version better. Now, sometimes your random process includes mutually exclusive events, also called disjoint events. These are events with no common outcomes, so they can never occur together. So that's the probability of A and B happening is 0. So for example, if the probability of the red one being a 5 and the blue one being an elephant was going to be investigated, that can't happen because the blue one can't be an elephant. On the other hand, we could look for one outcome or another. So if you're looking for the addition rule with mutually exclusive events, if we can only have R be one thing and B be another thing, or A be one thing and B be another thing, then the probability of A happening or B happening is just the probability of A plus the probability of B. So for example, suppose you tear open the corner of a bag of M&Ms, you pour one candy into your hand, and then look at the color. According to Mars Incorporated, the probability model for a bag from its Cleveland factory is as follows. Why is this a valid probability model? So first off, all outcomes are listed with probabilities. And they do say it's valid, but we should also double check and make sure that's true. Do all of these probabilities add up to make 1? Is there a 100% chance that the next M&M that falls out of the bag is one of these colors? Yes. Those are the 3 things you need for a valid probability model. So what's the probability that you don't get a blue M&M? So that would be probability that you don't get a blue would be 1 minus the probability that you do get a blue. So that would be 1 minus 0.207 or 0.793. Again, you could have just added up all the percentages that are not blue, but doing subtraction once is a little bit faster than adding 5 times. Now we can do a mutually exclusive. Something can't be both orange and green at the same time. So what's the probability that you get an orange or a brown? So the probability that you get an orange M&M or a brown M&M, again, is the probability of getting an orange plus the probability of getting a brown. Let's go BR for brown. since we already used B for blue. Probability of orange was 0.205. The probability of brown was 0.124. So altogether, that has a probability of 0.329. There's a 32.9% chance that your next M&M is either going to be an orange one or a brown one.